314 NPM packages just got compromised. This includes 271 packages from the Audit organization and popular tools like eCharts for React. This is not just a bad week for security, it is a systemic failure of how we trust our dependencies. By the end of this video, you will have a concrete defense-in-depth strategy to protect your builds from attacks that automated scanners miss. The recent incident exposes a critical blind spot in the way we manage software supply chains. We often assume that running a security scan is enough. We run NPM audit and feel safe. But when 314 packages are compromised in a single wave, it proves that scanning alone is insufficient. The attackers did not just target one library, they weaponized the publish mechanism itself. This suggests a compromised maintainer account or a sophisticated supply chain attack that bypassed the initial trust we place in the registry. Here is the thing that keeps junior engineers up at night. They think the solution is to update their packages immediately. They see the news, they run NPM update, and they feel like the problem is solved. But the reality is far more dangerous. Once a malicious package is published, the code may have already been cached in your CI/CD build artifacts or local node modules folders. Deleting the package from the registry does not remove the poison from your system. If you rebuild without a clean slate, you are rebuilding the exact same compromised architecture. This brings us to the first pillar of a real defense strategy. You must treat every dependency as untrusted until it is cryptographically verified at build time. The .v incident showed us that 43 of the 31.4 compromised packages were not direct dependencies. They were transitive dependencies propagated through indirect chains. This means that auditing only your direct dependencies is a fatal flaw in your security posture. If you trust the registry to tell you everything is safe, you are trusting a system that is too large and too fast for humans to police manually. The sheer volume of affected packages indicates that the ecosystem is under immense pressure. Maintainer burnout is real. The scale of the NPM registry creates a vast attack surface where trust is often misplaced. Automated scanning tools are reactive. They detect known signatures after the fact. But attackers are moving faster than the human response time. By the time a scanner flags a new threat, the malicious version may have already been distributed to thousands of developers. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. So how do we shift from reactive scanning to proactive verification? The answer lies in lockfile integrity. You need to stop trusting that the registry will always serve the correct version. Instead, you must verify that the installed tree matches the exact verified state defined in your package-lock.json file. This is the concept of verifying the lock file rather than trusting the registry. If a package is compromised, your build pipeline should reject the artifact if it does not match the cryptographic hash in your lock file. Now consider the specific challenge of living off the land attacks. Standard vulnerability scanners often fail to detect malicious code that mimics legitimate functionality. In the case of visualization libraries, the payload might be obfuscated or designed to look like normal data processing. Static signature matching cannot catch this. You need a shift toward behavioral analysis and runtime monitoring, but that is difficult to implement for every single dependency. The most practical solution for a production environment is to enforce strict build time validation. This means combining NPM audit with strict pinning of your package-lock.json. You should set your audit level to high to catch the most severe vulnerabilities, but more importantly, you must purge your cache before every build. This is a non-negotiable step in your recovery protocol. If you skip the clean build, you are risking that a cached version of a compromised package will be installed again, regardless of what the registry says. This approach requires a change in mindset. You must architect your build pipelines to treat every incoming dependency as a potential threat until proven otherwise. This is not about paranoia. It is about acknowledging that the ecosystem is vast and that human error or compromised credentials can happen at any level. The most critical career skill you can develop is not just installing packages, but designing systems that fail safely when trust is broken. There is a specific technical nuance here that many developers overlook. Sometimes malicious payloads, like crypto miners in debug packages, fail to execute in specific environments like Node.js due to runtime checks. This creates a false sense of security. Just because the code did not run in your local development environment does not mean it is safe in production. The runtime environment in your CI/CD pipeline might be different. It might have different flags, different node versions, or different permissions that allow the payload to execute. This gap between local testing and production reality is where the real danger lies. Attackers know that developers often test in isolation. They craft payloads that trigger only under specific conditions that are rare in development but common in production. This is why you cannot rely on the fact that your code runs fine locally. You must verify the integrity of the build artifacts themselves. The rapid pace of automated scanning versus the slower human response time highlights a critical gap. Attackers can distribute compromised versions before detection. This means that by the time you see a security alert, the damage might already be done. The only way to close this gap is to make your build pipeline the gatekeeper. If the build fails the integrity check, the deployment stops. No exceptions. This forces a culture of verification rather than a culture of hope. Implementing this defense in-depth strategy requires discipline. You must audit your dependencies regularly. You must check the integrity of your lock files on every build. You must purge your cache before every deployment. These steps might feel repetitive. They might slow down your workflow slightly. But they are the difference between a secure system and a compromised one. The cost of a single supply chain attack far outweighs the time spent on these verification steps. The JauntV incident is a wake-up call. It shows that the current model of trust is broken. We cannot rely on the registry to protect us. We cannot rely on automated scanners to catch everything. We must take control of the build process and enforce verification at every step. This is the only way to ensure that even if a package is compromised, your system remains safe. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.